Hello, this is Mr. Wolf, and today we are going to be talking about subtracting mixed numbers. And we're going to have a focus on when we need to regroup. So if we look at this equation, we have a subtraction equation. And I suspect most of the time when you do subtraction, you don't leave it horizontal like this. You stack it up vertically. And I'm going to do the same thing. I'm going to rewrite my problem. But instead of having it horizontal, I'm going to make it vertical. 3 2/8 minus 1 5/8. And you'll notice, just like when you're doing subtraction with numbers that have ones and tens and hundreds, and you separate out your columns, you're going to do the same thing with mixed numbers. I have a column for my whole numbers and a column for my fractions. And in this equation, we're starting with two fractions that share a common denominator. I wouldn't even stack them up until I have my common denominator. I have a common denominator, and so I'm only going to subtract the numerators. But I have 2 minus 5. And that's not something I can do. I can't do 2 minus 5, not in 5th grade. So what I'm going to do instead is regroup. And just like I would be able to take 5 tens and split that into 4 tens and 10 ones, I would be able to regroup. I can take this 3 wholes and split it. So now it is 2 wholes and 1 whole. And I want to be able to have a 1 whole I can add to my eighths. So I'm going to make it 8 eighths. Now this is the part that can be a little tricky because we're so used to adding 10 when we're working with whole numbers. But this is 1 whole would be 8 eighths. 10 eighths would be a lot more than 1 whole. And actually, when we add the 2 plus the 8, I'm going to now move this whole thing over. I now have 2 and 10 eighths minus 1 and 5 eighths. And this is a problem I can do. 10, so I know it's going to end with eighths because it has a common denominator of 8. I'm going to say 10 minus 5 is 5, and 2 minus 1 is 1. So 1 and 5 eighths. That would be my answer. I'm going to do one more just so we get a little bit more practice. In this case, we're going to have to also convert our fractions. Here I have 5 1/2 minus 1 and 5/6. And like I said, I'm not going to stack this vertically until I have a common denominator. So I'm going to give myself a little bit of space to figure that out. Now I can look pretty quickly, and hopefully you see this right away. Maybe right away you say, I know 2 can go into 6, and 6 would be the common denominator. But if not, let's look at how you would do that with our factors. You would say 2 and 6. You would say, all right, well, 2 is its own prime factor. It can't be broken down. 6 is 2 times 3. And we can look at what do 2 and 6 share? Well, they share the 2. And now we can go with the strategy we always use. We say, well, let's write what they share first. They share a 2. What don't they share? They don't share the 3. That only shows up in the 6. And that's everything. And we know 2 times 3 is 6. Our common denominator would be 6. And so I'm going to now convert my fractions. And because I know I'm going to have to stack, I'm actually going to use down here to convert my fractions, especially I only need to convert my 5 1/2. So I'm actually going to do my vertical stacking, where I have 5 and some mystery number of sixths minus 1 and 5/6. And I just now need to fill in this blank and I can do my math. So I have 1/2. I don't want 1/2, I want 6ths. I want to keep its identity. I want to keep its value. So I'm going to multiply by 1. That's the only thing I'm allowed to multiply by. And I'm hoping everyone, you can look right up here and say 2 times 3 equals 6. We need a 3. And if we have a 3 on the bottom, we need a 3 on the top to make it so it stays equivalent to 1 whole. 1 times 3 is 3. And I can fill that in. But as you probably predicted, we now have a little bit of a problem. My answer is going to be in the 6ths. But I don't know how many yet because I cannot do 3 minus 5. So I am going to take my 5 wholes and make it 4 wholes. And I'm going to add in 6/6, 1 whole. So 4 plus 1, 4 plus 6/6 is the same as my 5. And so now I'm going to rewrite my subtraction over here and say 4 and 9/6 minus 1 and 5/6. And that's going to equal some number of 6ths and maybe a whole number as well. I can go 9 minus 5 equals 4, and 4 minus 1 equals 3. And this, in many cases, would be a fine answer. This would be an acceptable and appropriate answer. But if you want the best answer, you might notice something. You might say, I know that 4 and 6 share a factor. 4 and 6 both share a 2. And what you can do is just like we can multiply the top and the bottom by the same number, we can divide the top and bottom by the same number. So if I divide it by 2 on the top and divide it by 2 on the bottom, I'm not changing anything. It's staying the exact same value. It's just changing its appearance. I can look at this and say 4 divided by 2 equals 2. 6 divided by 2 equals 3. 4/6 is the same thing as 2/3. And so we could write 3 and 4/6, or we could write 3 and 2/3. So that was our regrouping when subtracting with mixed numbers, and we got a little bit of simplifying as well. I hope this was helpful, and I will see you again soon.